Hello everyone, let's start our sprint demo meeting for sprint 1823 for Indy teams, for Indy Node and Indy SDK. This sprint for Indy Node team was devoted to more stability and bug fixing, in particular memory leak researches and fixes. In the scope of this work, we found and fixed one problem and also investigated RocksDB and ZeroMQ memory consumption. Also, we continued the work regarding test pool automation. So now we have more or less ready-to-use scripts to start test pools on demand. We continue other stability fixes, and also we continue improving our public documentation and working on some diagrams. Also, it's worth mentioning that we are working on deprecation of client code in Indy Node, and in particular, we already migrated to SDK for all integration tests within Indy Node. So in the next sprint, we will be ready to fully remove all the deprecated code. As for SDK, the sprint was devoted to continue working on Rust wrapper, also some bug fixing, and support of community in terms of reviewing of pull requests, in particular Postgres and other requests.
Yeah, one of the results of current sprint is urgent 1.6.8 release, and as a result, we have some tickets in validate state because we don't have a CI time for producing of releases and testing of this functionality. Yeah. Also, QA team was assigned for testing of new release instead of bugs validation.
Yeah, so it was an urgent task for both SDK and Node team. So we found an issue of slowness and hopefully fixed it more or less fast. But yes, it's affected a bit sprint scope and our CI/CD resources. So as for the demos, we're going to have two demos from SDK team, one about Rust wrapper integration from Nikita, and one about the urgent release that was just mentioned from Sergey. And for the Node team, we're also going to have two meetings. One is about recent findings of memory consumption and a leak found in plenum code. So it's kind of a detective story on how we suspected it and how we finally found and fixed it. And also we're going to present a new sequence diagram for plenum consensus protocol based on RBFT and how it's different from RBFT and what are specific of plenum. So let's start with Nikita and Rust wrapper integration.
Nikita, I can hear you. Oh,
I think I fixed. Yeah. So what was with Rust wrapper? We received it, but it was written in a style like there were 3 endpoints for each call of libindy, one for timeout, one for racing, and one for synchronous call. And we were not. It was okay to use, but we were not really satisfied. And we decided that it would be much better, much much more usable if we would implement it in futures. And so that's what we've done. I will show you an example of how it looks now and how we can consume it. Let's take DID as an example. So what we have now, we are returning future. Future is the type that can be resolved somewhere in the future, and we can wait for it, or just place a callback that would be executed on a future completion. So it can return, like for the create and store my DID, it can return if the future completes successfully, it can return a DID and a var key, and if it completes with an error, it will return an error code. So that's how all the Rust wrapper is now written. However, if you want to still consume symbols for like C library, you can just import indices crate that contains just plain symbols. And I want to show an example how how the client like Indy CLI has been changed with this new functionality. So that's how all calls to the Libindi from CLI looked before. It was just we should have created a callback and then map all the parameters of the function to send them through the C interface, and then we made an unsafe call and so on, and then we waited for this channel to for the result on the channel. And now we just call the Rust wrapper, and if we need a synchronous call, so we just waiting for the result. If you need to have, if you need to have, if you need an async result, you can just use something like and then, and here you can just put your function, which is a Rust function, not like an external symbol. And it will be executed on a callback. That's it for that demo. So if you have any questions, you can ask it to me or anybody in the SDK team.
I have a question. Do we use Rust wrapper for implementation of, for example, testing of Libindi? What we have.
For testing of Libindi, we also use a Rust wrapper, and we use Rust wrapper also for testing of plugins, but not for their implementation. So here we can see. Oh, I think my idea is can just catch everything right now because we made some tricky things with the compilation of Libindi tests, and it just can't catch up right now. But this is just the call to the wrapper that will call Libindi. Then, so and here is just synchronous call to. So that's it. Libindi tests also use the Rust wrapper now.
And what about VCX? Does it use?
VCX is also it now also uses Rust wrapper, but let me find it. It's pretty hard for me because it wasn't the part that I implemented. I think I'll just go this way. Oh, here it is. So like that. I'm not pretty sure that what this part is doing. It's again using tests. But it uses, it also uses the wrapper, and I don't think that it consumes anything from the C symbols.
Okay, thank you.
Okay, thank you.
I'm stopping sharing. Yeah.
The demo. Yeah. The next demo is from Sergey, and it's about the hotfix release 1.6.8.
Thank you, Alex. Hello, everyone. Let me share my screen. During this sprint, we have one urgent release, one urgent report about slowness between Indy SDK and Indy Node somewhere. An initial step, we don't know where it is, but after some investigation, we detect the current case. And this fix is the main reason of one new release of Indy SDK. The new version is 1.6.8, and this release is now in stable. So you can find, as usual, release tags in GitHub and appropriate artifacts on repository.org in appropriate folders. Let me share some more details about the slowness problem. As you know, Indy network in general use some combination of state proof and BLS multi-signature to optimize read request. This combination allows to send the read request just to one node, and from single response, check and verify consensus of the whole network. But after deploying the latest version of Indy Node to one of the most popular and large sovereign network, we detect some slowness, some performance degradation. Unfortunately, this degradation wasn't detected on test networks or due to our loading test, because read request is not our primary interest. But in real life, we detect this slowness and start investigation. We detect that the reason is changes in Indy Node to client communication, Indy Node to Indy SDK. It's not some broken changes and broken communication, but it can slow the communication. So we decide to produce new release 1.6.8, and this release contains, as the main part, is as the fix for this problem. Also, it contains some cleanup in loggings and updating for CLI helps. Let me also share the test. We have some integration tests for this purpose. I wouldn't like to start it from scratch because it takes a while for preparation. But in the end of this test, for example, we perform GET requests for credential definition. And in the trace logs, we can double check that the response come back from single node in the single response is enough to provide a value for application for the user. You can see signature verification and proof verifications. I mean state proof. And state proof here correct test and signature, so test is passed. That's it from my side. Thank you.
Thank you, Sergey. So let's move to Indy Node and the demo from Sergey K, and it's about detective story about how he found an issue in plenum related to memory.
Hello, do you hear me?
Yes, we do.
And hopefully you can see my screen now. Well, this is quite an old issue that was found in the beginning of October. At first, it seemed like a minor one. In the beginning, it looked like during long load test, much time taken by a looper was increasing, and increase is quite significant. This was it was decided that it was a minor bug because average time wasn't affected, but maximum time was increasing. Maximum time increased almost tenfold. Here is a logarithmic scale. After some time, there was a hypothesis that this increase in loop max time was due to garbage collection. And if it's due to garbage collection, then there might be a memory leak. So we added some metrics that show number of live objects. And indeed, it turned out that we had a memory leak. So it was indeed a garbage collector that took increasing amount of time, as can be seen on this graph, and number of live objects was steadily increasing during long load test. It turned out after we added some more metrics and some debug output, it turned out that it was indeed a leak in one of our collections. It was actually ordered set that contained all ordered prepared set numbers. We fixed it by replacing it with the interval list. So this prepare sequence number are continuous. So basically, no matter how many of them we store, the amount of memory taken by interval map is the same. And after this fix, number of live objects tracked by garbage collector is steady and it infers resembles very closely number of requests in our queues. So the problem is fixed. That's all from me.
Thank you, Sergey, for the demo, for the research. So the last demo is about improvements in our public documentation, and in particular, we created a sequence diagram for the plenum consensus protocol. So let me quickly show you this diagram. This is a new diagram. In general, plenum is based on RBFT protocol for consensus, and this is a PBFT-based leader protocol with an F+1 instances of the protocol. And actually, this part is a core of plenum, the main thing which allows plenum to order transactions in predictable order and keep the ledger in sync. So the diagram is started by four core items where plenum implementation of RBFT is different from RBFT paper from theory, because plenum has some improvements. So in particular, plenum operates around the concept of batches of requests instead of just ordering every single request. Also, in plenum, consensus is combined with validation of transactions and optimistic applying them to the ledger and state. Plenum also has a concept of timestamp added for every ordered transaction, so that we can check for freshness from the client side. And the last thing that BLS multi-signature is integrated into consensus protocol, so that it allows to clients to send requests to only one node and get reliable result for read requests. So the diagram is a sequence diagram, but it has it gives a general overview about all the essential steps and has a description at the right side for every step. So the three main parts here. The first part is write request from the client and how it's propagated between nodes. In this diagram, we consider an example of 4 nodes because this is the minimal number of nodes required for consensus, where F value is 1, so it means that we can have 1 malicious node. And the first phase just shows that the client needs to send a request to every node. Then this request is propagated to every node and forwarded to replicas. Then the main part of this diagram is the so-called 3-phase commit. And important thing here is that RBFT has F+1 protocol instances, where only master instance is doing a real job of ordering and applying requests to the ledger and state, while F redundant instances are needed only to measure and evaluate performance of master, and it's needed to trigger a view change in case of degraded and poor performance. So we can see a loop here. So the same steps are generally done for every protocol instance. An important thing that here for simplicity, we show that node 1 is a primary for master instance, but for backup instances, primarily should be different node. So for backup, it will be usually node 2. But here for simplicity, we assume that node 1 is a primary and show it for master instance. Also important thing here that the steps, the master instance, the main instance has more work and has some additional steps not present on backup instances, and this is marked with blue color. For example, master instance has validation steps for validation of requests and applying them to the ledger and state, and also some steps dealing with BLS signature and multi-signature. While backup instances has just 3-phase commit phases and without any additional work. So 3-phase commit, it consists of 3 main phases. The first one is pre-prepare, when the 3PC batch is created. Batch of requests from the client is created and applied to the state and propagated to all other nodes. The second phase is prepare, when we also validate this pre-prepare and successfully validate it, and send prepare to other nodes that we agreed upon this pre-prepare. And the last step is commit, and it also includes dealing with the BLS signature and signing each 3PC batch of requests. And once we have a quorum of commits, the requests can be ordered. That is, it goes back from replicas to node, and it's executed. So again, the main purpose of this, the whole process, is to have the same order, the same sequence of transactions on all the nodes, which guarantees, in addition to checks of Merkle tree roots, that all ledgers are in sync and transactions are replicated in the same order. And execution is actually committing already uncommitted state to ledger end state, and we send replies to the clients. So this is it provides a high overview of the diagram. And next sprint we are planning to continue improving and having more sequence and other types of diagrams in addition to text documentation that we already have. Okay, so that was the last demo, and a couple of words about plans for the next sprint. For the Node team, well, for both teams, the main goal for the next sprint is the creation of the next service pack release. It will be 1.6.79 for Indy Node and 1.7 for libindy. For Indy Node, we have a couple of improvements and stability fixes that we need to integrate into this release. And after this, we are going to start preparing the next major release of Indy Node 1.7, and it will contain also more stability and improvements fixes, as well as new features, for example, multi-signature support, improvements and changes in validator info, and so on. So also, as you can see, we are going to continue working on more diagrams and public documentation in the next sprint, as well as removing deprecated client code from Indy Node code base. And also more exploratory testing and load testing is expected. As for SDK, as I said, the main goal is release 1.7.0. And well, also continue on bug fixing and VCX improvements and features. So that's basically all for our sprint demo. Does anyone have any questions or comments? If not, then thank you and goodbye.